Right, so back in 2018, four tall Dutchmen had a dream of bringing autonomy to agriculture globally. Just so happened back in 2018, legislation around autonomous vehicles changed to allow unsupervised autonomy to be real, legal, and practical for farms around the world. There is a big difference between supervised and unsupervised autonomy that we'll come to later. So key criteria were that autonomy should work alongside conventional tractors. So the brief was use diesel fuel while alternative fuels are coming along at great rate. Today in the corner of farmyards around the world, diesel is still the most popular option. The three-point linkage shares its 100-year anniversary this year, and again, universally, globally, three-point linkage is something that's unanimous with agriculture. And then finally, we needed to outperform Europe's average tractor. So back then, tractors were around 145 horsepower as an average. So this was designed to outperform, outlift, and outpull. So from there, the four engineers quit working at Rogator, Agco, and set off on this path of to autonomy. They built the first machine very similar to what you see here today. It took them 15 months to build the first prototype. That was a remote control version, and 3 months later it was fully autonomous, and they were out testing around Europe to gather their thoughts on how this would integrate and challenges in bringing autonomy to farmers throughout Europe and beyond. 3 years after that, they sold the first Agbot into 2021. Machines been sold through Holland, Belgium, into Germany. First one exported to Australia, and then from there now we're up to 120 machines globally, 26 dealers, selling a range of Agbots. This is the largest in the range that Will here is going to talk about in more detail. We also offer a four-wheeler version. There are all of those working in Kent and throughout Europe, and then right at the small end we offer a three-wheeler version which works in orchards and vineyards, typically spraying. Right, so we're going to bring the machine in, and Will's going to run you through the mechanics of the solution. I'm just going to talk about autonomy. Many farmers' sons, like us all, could have a go at building a robot, but the challenges of producing such a device like this are really down to the digital side, the homologation, and the redundancy. These machines are built with a range of sensors that gives you the perception system, so that these can legally be left running around fields around the world unsupervised. You can go to bed, leave them running. Objects, people, animals that appear in the periphery of the machine will bring it to a stop. It will notify you, the operator, and notify you and give you the options as to what you'd like to do before finishing the rest of the field. Right, Will, I'll pass it across to you. Can we just take this fence down, and we'll bring the machine through.
All right, thank you, Peter. So what we're going to do, we're going to bring the machine to a stop here somewhere, drop the fence so we can have a good look around it, and I'll walk around the machine and give you roughly what the specs are. As Peter said, we've got three machines in the range. This is the larger. The four-wheeler is a 75 horsepower machine. Typically we see that doing lighter operations, so weeding and planting, and quite a lot of grass cutting. The three-wheeler is specifically designed to do row crop work in terms of orchards and vineyards, specifically designed to run up and down rows. We haven't yet sold one of those in the UK, but we will do shortly. While I'm here, is there any questions? Anyone got any burning questions? Sorry? Yeah, number of units in the UK. So currently we've got 6 track machines in the UK and 3 four-wheel machines in the UK. So Peter's now taking control of the machine. If you notice, the lights on the top are now solid green. When it's in autonomy, they are rotating yellow and green, but we now know that this machine is being driven manually because it's got a fixed green light. We can do everything from the controller, so we can lift the implement up and down, lift the front linkage up and down, and drive the machine fully remotely when we need to. So we'll start with the track system. We can supply anything from 300 to 950 mil tracks. We prefer in the UK the 610s or the 750 tracks. Gives us a good balance between traction and floating across the soil. The track frame is different and the rollers are different each time we change the track size. So we don't just put a wider track on, we actually put wider rollers on. The 300 mil tracks are on a completely different track frame for row crop work. On the rear of the machine, we've got a Cat 3 3-point linkage with an 8.2 tonne lift capacity at the hooks. The machine itself weighs about 7 tonnes, so if you want to lift an 8-tonne implement, we want a fairly hefty front weight on it. As any conventional tractor, we've got 4 spool valves on the back. We've also got power beyond or load sensing, and we've got a bidirectional PTO, capable of running at any speed from 0 to 1100 RPM. So if we want to put what would have been a front implement on the back, we can reverse the PTO and we can run the machine effectively backwards. On the front, we've got a Cat 2 front linkage, capable of lifting 3.2 tonnes. In the UK, we spec the machine with a 1400 kilo front weight, with a toolbox one side and a 250 litre fuel tank the other. The machine itself has 350 litres on board. If you really put it on its knees, you can consume that in about 14 hours. Gentle work, rolling, that sort of thing, typically we see upwards of 30 hours out of a tank full. So with the additional 250 litres on the front, you're pretty confident that you've got a complete 24-hour working period. The implements of today, the smart implements, this isn't a smart implement, but a lot of manufacturers are now coming up with smart implements, and we can retrofit some smarts onto implements. Typically, a smart implement would have a sensor on the roller at the back, so if the roller stops, we can command the Aggbot to do something. We have point wear sensors, we have shear bolt sensors, and we have blockage sensors. And the implement has the ability to command the Aggbot to do things. So i.e. if it blocks, we can lift up, drive forward a few metres and let down again. If it continues to block, we can stop and then send you a message. On the top of the machine, the little blue round thing at the top is the LiDAR. That is scanning 0 to 30 metres. So as you come into that 30-metre zone, the machine will start taking notice of you and seeing or trying to determine what you are, whether you're an animal or a human. When we get within 12 metres of the machine will start to slow down. On these particular robots, purple lights around the top indicate that it's seen you or seen something. So that's the primary safety feature. Also on the top, we've got a front and rearward facing camera, which is connected to an app or an internet portal. So while we're operating this, we can look on our phone and we can see the progress of the implement, and we can also look at the front and rear camera. Additionally, on the front, we've got a radar that scans 0 to 15 metres. We've got sonar ultrasonics, similar to your parking sensors, does 0 to 2 metres. And then the front bumper is actually a soft bumper, which is a hard stop. So if that bumper was to run into something, the machine would come to a full stop, and we would then need to return to the field to restart it. If the LiDAR sees something, it will slow down, it will eventually stop. You'll get a message on the app, and you can actually look at it and then make a decision. You can say, okay, what's that? Oh, that's my next door neighbour, let me flatten him, carry on, go. You actually make that decision. We are able to use these, let these run fully autonomously. So putting them into a field at night, going home, going to sleep, that is a real possibility. We don't have to be with it. We don't have to attend it. Nobody has to be watching it. They are able to be used fully autonomously. Typically, we see implement sizes on the back anything from 3 to 6.5 meters. We have got one customer pulls a 12-meter set of rolls, 6-meter Simba Colty press. We've got one customer pulls a 5-leg subsoiler quite confidently with it. So they are a very, very capable machine. Anybody got any burning questions? And Peter, have I missed anything? What sort of gearbox? Very good question. So it's actually a diesel electric transmission. So the 155 horsepower diesel engine runs a generator, and that runs 2 electric motors on the tracks. That is the most efficient way we can get that 155 horsepower onto the ground. It's the most efficient transmission we can have. Roughly how much do they cost? So depending on the spec, one of these could reach 317,000. The 3-wheeler would be somewhere about the 150 mark. Used machine. This one, if you'd like to take this one away today, probably somewhere about 210,000. Yeah, we could sell it, couldn't we? We could have a quick impromptu auction.
How do you go about moving it from field to field?
Very good question. So from field to field. So currently we are a single operation. So we go into one field and we do that operation. The machine stops. We then move it to the next field. Very shortly we are going to be able to move from field to field, provided we don't have to go on the public highway. So we can move from field to field through a safe gateway. If you have to go on the public highway, it's a low loader job. So we stick it on a low loader and move it to the next farm. So we do not see at this stage a battery being a sensible option for a draft implement. So if we were to take the biggest car battery that we could find and put on this machine, it would last somewhere between 7 and 17 minutes, depending how hard it was pulling, provided you could get the power out. So at this moment in time, battery technology isn't where we are for heavy draft work. If we had a 4 or 5 or 6 stepped change in that technology, it might be something, but at the moment it's just not there for us. Sorry, Mr. Question here. Yeah. So bridle paths and public footpaths are okay. It depends a little bit on your insurance company. Our insurance company are insistent that if there is a public footpath or bridleway, it is marked at either end, clearly marked that there's an autonomous vehicle operational in that field, and then they are happy for that to work. So, yeah. What's holding back the higher horsepower? Well, the original dream of this was to produce a lighter implement that didn't damage the soil structure. So this was where the weight that was wanted. I mean, typically we find that this machine is doing 100 acres a day because it's running for the 24 hours. So at the moment, we're happy with this size machine, and our customers give us good feedback on the work rates that they get. But no aim to go any bigger at this stage. We might change our view, but at this stage, this is where we are.
So you're saying then that this would replace a normal tractor that would do this sort of work would be a lot heavier and
yes, yeah, a lot. So you know, we can run this for 22, 24 hours a day comfortably. You'd want a much bigger machine to do the same, get the same output with an operator.
Do you see these fully replacement tractors or working with tractors sometimes in the future?
Well, as I'm the UK seller, I would hope that they would obviously replace every tractor that's out there. You're always going to need to haul product. You know, you're always going to need to move stuff around. You're going to need to do operations that won't be autonomous, hedge cutting, that type of thing. And it's a good question. I've got a small farm at home, and we're sort of introducing this fully into the farm. And now the next thought process is, okay, if this machine is doing all the cultivations, what do I then need? do I need a conventional tractor or do I need a high-speed tractor because I'm doing a lot more hauling? You know, how does that work in terms of the business and how does that structure into the business? But it's a good question, and it's a question we probably haven't fully got the answer to yet. You must have had another burning question.
No, I can come to when you're done.
Any other final questions? Go on. So we do have a retrofit smart implement controller, so we can retrofit onto any implement, you know, various sensors across it. Some of the manufacturers are beginning to bring out smart implements, so you see that creeping into the marketplace today. Yes, yeah. Yeah, so there's every sensor you can imagine on this. You know, we measure the oil temperature, the oil level, the water temperature, the water level. We measure everything. We even measure the hub temperatures. And if any one of those parameters goes out, you know, is not in where it needs to be, the machine shuts down. With a hydraulic oil level, you get some early warnings. So if the oil level's dropping, you know, you get oil level low, but eventually it will shut down. So, yeah. Very, very good question. So there is a 5 kilowatt, 700 volt socket on the back. So that's designed to take the latest or the future ISO bus electrically powered implements. And if you think about that, if we take something like a power harrow today, we've got a PTO shaft, a gearbox, and then a bed of gears. If we had a fully electric power harrow, we just have a motor on the top of each rotor. And then start measuring the load on each of those rotors. You can then determine if there's a blockage, if there's a broken tine. You can determine very quickly from that. I mean, it's 700 volts DC, so you'd need to convert it back. So you'd want a fair size converter. Yeah. Any other final questions? Just looking round. Now back to you, Tom.
Thank you very much indeed to Will and Pete from Agxeed. And did you give it a name? Did you ever name your robots, or is that just silly?
No. So every robot has a two-word name. So we name every robot. So this is Dawn Mountain.
Well, thanks very much to Dawn Mountain as well. Okay, everybody, we're going to have, continue in the world of machinery and arguably robotics, we're going to do drones next. That does, I'm afraid, mean you've all got to move back to the other side of that fence line from where you were, and there will be a talk and a display about drones and agriculture right here.